so next we're moving on to multi-class decision rules. And this is in the case in which we want to classify more than one labels. For example, let's say you have 3 cases, then you have a weight vector for each class that you want to classify. So in this case, you would have W1, W2, and W3 for each of the 3 classes right here. And then this is just like the binary case, where you compute your activation, which is just the dot product between the weight vector and the feature vector. But what you do instead is, instead of in the binary case, is you just compare the activation for each of the 3 vectors, and you pick the highest activation, the weight vector corresponding to the highest activation, and you choose that label as your classification. So you compute the weight vector, you compute the dot product between all the weight vectors for each of your classes, and the highest score wins. And then, so what this looks like in the binary case, you have 2 classes, but you only need 1 weight vector, because actually in the case of binary, you'll have 1 weight vector, which is your original weight vector that we saw before, and the weight vector for the other class is going to be exactly in the opposite direction. So in the binary case, you only need 1, because this is just your second weight vector will just be negative wy. So then you'll have more than 1 decision boundary, and then all the points in this region will be classified as the 3rd class. All the points in this region will be classified as the 1st class, and all the points in this region will be classified as the 2nd class. And one thing to note is that in this case, it's not just the angle between these weight vectors that matters, it's also the magnitude. Because if you double the magnitude of one of these weight vectors, then the activation will also be doubled. And therefore, you might get more, you'll be comparing the dot product between these 2 vectors, and one of them will win if it has a lot higher magnitude than the other.